Okay, so I should say something about how to define OR. So basically, if we have the subobject classifier, we can form this coproduct here. And then these are our kind of coproducty paired arrows denoted by the squared brackets. And then we have this arrow true, comma, identity, identity, comma, true. And if we take the image of that, as in we do a kind of epi-mono factorization, and then we take the subobject classifier of it, that gives us our OR arrow. And indeed, that will be an arrow from omega times omega to omega. Right, so some practice with doing inference in the Mitchell-Benabou language. Now we have all the constituents. And so here's an example inference. We start with nothing, and then we get this trivial sequence that file psi implies. Not file psi implies not file psi. And then using the connective rule 1, we get this. Taking this knotted thing onto the left. And we get that this stuff implies false. Then we can do some thinning, introducing a phi onto the left. And we have all this stuff implies false, and then we can use the false rule again to take this not thing well, we get to here. We can do a similar one with size, and we can do a cut. Let's go through this one because this is my favorite. There's many of these, but this is exercise 14.1. So the thing is, in topos logic, we're not allowed to use the law of the excluded middle. But we can still show a contrapositive. So let's say that we have this we're supposed to sequent phi implies psi. Now we want to deduce that not psi implies not phi. And recall we have this cut rule that if A and B implies C and A implies B, then A implies C. So here we go. We start with two different sort of chains of inference. On the left, we start with nothing. Well, actually, no, we don't. We start with this assumption here that phi implies psi. And then we do some thinning. We add this not psi, and we call. So we get phi and not psi implies psi. The other chain of reasoning, we start with nothing. We get not psi implies not psi, trivially. And then we use our not rule, and we get psi and not psi implies false. And then we do some thinning, introducing an extra psi, and we get psi and not psi and psi implies false. Now let's take A to be phi and not psi, and B to be psi, and C to be false. So we have A implies B, we have A and B implies C, so we get A implies C. So we get phi and not psi implies false. And using the not rule, we get not psi implies not phi, which is what we wanted. So we've managed to infer this without using the law of excluded middles.